All right, welcome everybody. This is SIG Scale. It's February 19th. All right. Topics for today. So Vishnu, we've got your PR. You want
Yeah,
to talk about this? Go ahead.
yeah, I'll go real quick. Yeah, I just need a review on the first one in the cube word, 16768. And the next is follow-up. So yeah, we'll let the first one go first and then go with the follow-up and Project Emperor.
Okay.
Uh,
Awesome.
Vishnu,
Sorry, go ahead. Lee.
can you just let everyone know what the plan is? It seems like this job is just an addition and it's not breaking anything.
Yes, correct. So this is just a addition to add Kubernetes test. So once this PR is merged, my plan is to get the project infra PR, which has pro config merged, and then run a quick test. So this is going to emit all the data in the JSON format, which is relevant to KubeBurner. So I'm going to open up a follow-up to post-process that JSON data to fit in with the current format that we have. That way it gets rendered into all the plotly visualizations that we look at. So that's the plan.
Lee, go ahead. You have a question?
Yeah, I think we should since KubeBurner allows us to put data into other indexers like maybe Grafana or ELK stack. I I'm not sure if creating that converter logic and putting it into the same stack is the right approach. I think we should explore moving to something more persistent like Prometheus or Grafana after this test is merged.
Okay, so I mean, our team has been playing around with Prometheus, Elasticsearch, and Grafana for a long time, but there are a few issues with Grafana. The thing is, I mean, we'll have to stick to the visuals that it brings in inbuilt, and sometimes it has issues with loading data if it's in large amount. So it has its own problem. But yeah, I will let you guys decide on that. Wherein Plotly is far simpler than what Grafana is. I mean, Grafana will look good at the start, but as we keep on indexing more data into the persistent data store, which might be Elasticsearch or Prometheus, whatever we end up deciding, when it tries to pull in all that data, as volume keeps on growing, Grafana keeps slowing down. That's
So
one
this,
learning I had for a long term.
yeah, no, our plan is to keep purging the data that is 6 month, well, maybe 3 month or 6 month old. So we don't really want to go and publish data that is 2 or 3 releases old, right? Ryan, correct me if I'm wrong. We don't really need like a lot of like 2 years, 3 years worth of data put into Prometheus.
Okay, so if that is the case, it might make sense. We usually prune all our 1 years of data, but we do have a lot of coverage downstream, so makes sense.
Yeah, so if that works, if you have 1 year of data at your downstream tests working, then I don't see why the data from this upstream test will be larger than those. I think this will be manageable.
Yeah, sounds like it. Yeah.
Lubo, does this work with you? I know we have Prometheus instances running, so my idea is that we'll move away from this Git repository that is storing the data and just go directly to Prometheus Grafana stack.
Hey, so how do you persist it for like years or such to be able to come back and retrospect?
So we don't currently persist it more than a year. Um, a year gives us three releases. We only support upgrade and downgrade of one release, so I'm not sure if we need more than three release worth of data.
Okay, but where do you run the Prometheus? I guess on our upstream CI, the CI is updated twice, maybe three times a year. Maybe it has an outage.
So we have in the past we have had Prometheus instances running, right? There might be a link to it in this agenda document, but I forget.
Yeah, there was. I can't remember though, but it's the stuff. No, no, that's not it. There, I do remember this though. Like,
Yeah, maybe Brian or Daniel will have more understanding of where that is hosted.
Also, some of the clusters are visualized with CI. Those clusters would need to have access to the metrics as well, which is not a problem. I think that's doable, but something to think about.
I'm sorry, I lost you a little bit, Lubo. Can you repeat?
Just saying that some of the jobs we run as SIG performance, yeah, they will need to have access to the Prometheus. So something to think about in the future. It's not like that it's not possible, but we will need to make it happen.
Yeah, makes sense.
But I still would be more inclined to say enable, like whatever instance of Prometheus we will use, we should have a persistence backend for at least a year as we do right now, to be able to reliably go back at least few weeks or months and see if we regressed or not.
Yeah, definitely. I agree.
And then I would assume per release we still do some summary which ends up somewhere like a blog post or repo.
Yep.
Just curious, how do we look at regressions as of today? Just looking at the graph visuals, or else is there like a tool that notifies us on the face saying that there's been this percentage change or so in a specific metric?
No, we usually review the plotly graphs that we publish here once a week, and the regressions, let's say after a few weeks, are pretty evident from the graph. So that's how, and then if that regression is worth digging into, we decide here on this call like what's causing it, and basically we have a way from identifying the date on the plotly graph to going back to the GitHub commit history and see where the issue is coming from.
I see. We have something downstream, but it's an open source tool. But I will hold on to this one to revisit later. Maybe I should focus on getting these tests done first, I mean, merged first, and then discuss about how do we do change point detection. I mean, basically the regression detection using one of our open source tools. But yeah, thank you.
so like, do we need to? Are there any changes that needs to be made in this PR to? Like, is there a dependency on Prometheus here, or can we start, or do we want to start with like what's in this PR?
No dependencies on Prometheus. This PR is basically code that will be executed through a pre-submit job that Vishnu has as second PR. So even if this PR has any issues, that pre-submit job that is following up is supposed to catch that. So we should begin with this PR as is and then iterate over it.
Okay, so we want it for persistence then. So persistence will be later.
Yes.
Okay, that'll be step 3. Okay. Okay. All right, so good. So I think then the action areas, we just need reviews and let's get feedback in and we can get this merged. All right. Good. All right, there is these are just some notes I added. There's another topic from Federico. I don't know if he's here. Did he make it? No, he's not here yet. Okay. I don't know how late he's gonna join, but let's just see. Let's go to we'll do a review of our data. And I think we also had some clock data we wanted to look at. Maybe we start with the clock data. Okay, cool. All right, so everything's here for the clock data. This is great. Okay. And I think the thing we care about is the memory. Okay, hold on. Let me do a quick side by side here. We're gonna open this up. We're API. Okay, let's take a look. All right, so let's see what is different here from our clock tests. Teresa, this is the right one, right? It's 132. This looks right. It's up to date. It's not 134, right? I can't. I'm just. It is 134. Oh, okay. So it's not this one. It's this one. Okay. Okay. So we have about a week of data on this. Okay. All right. So we don't have a ton, but let's just take a quick look. All right. So average third API mem usage in megabytes. Okay. So on our job of 100 VMs, real VMs, we're about 140. We're about 170 for. Can you remind us again, Shrija, how many this is? How many VMs is 1,000?
It's 8,000 VMs.
10,000. Okay, 10,000.
Um,
10,000 VMs.
I think it's 8,000.
It's 8,000.
8,000. Okay. Shrija, for some reason you're coming through very faint for me. I don't know if that's just on my end. I'm sorry about that. I couldn't. I mostly heard what you said. So okay, the so what are we at? So but 140, 170. Okay. Okay. I'm not sure what we should be seeing here. So what this is just taking a look and seeing, okay, 125. We see about 145 for the min, and then let's look at the max, about 175. Okay, interesting. These are somewhat similar. Okay, let's look at the CPU usage a bit more. The clock job. Okay, here we go. Average for a controller. Okay, now we see something that's pretty significant. So for a controller, we're about 60 MBs and we go to about 1400. So we go to over a gig. Okay, so there we go. And now we see like how the effect is. Interesting. Okay, so the vert controller is the one that really takes the load. The vert API seems to be scaling really nicely. Okay. Let's go to handler. Let's take a look.
So, Ryan, for the
Mhm.
word controller, uh, there is a new metric we introduced that gives us queue depth and queue processing times.
Do you
But
know what it's called?
I
Maybe I'll
forget.
spell it wrong.
Right.
All right.
She, was that metric also added to the graph, or we missed adding it to the graph here?
I think we missed adding it to the graph.
Ah, okay. So then we'll have to review it on the benchmark repository.
Okay, so we want to have the okay. So we do need so that'd be an interesting one. So what we do see here, I think what's interesting is the ever controller memory, clearly the way it's scaling, it's definitely scaling independently of the Vert API. So I mean that's good for the Vert API. I think we'll just have to think about the Vert controller and see if we can make sense of this. We don't have Vert handler data. Are we supposed to? Looks like it's all zeros. Or
No,
is
the
the Vert handler faked?
simulator, yeah.
Yeah, simulated. Okay. Okay. I think that's to me like the so you get some good observations here. I think this is the one we need to think about is like what's the Vert controller memory usage. This is probably the one we need to watch.
Regarding the simulated testing, I have one more topic. Since Lubo is here, but if Federico is here, then we can let him go. Otherwise, I can share.
I don't see Federico.
Okay.
Yeah, go ahead.
So, Lubo, I think we we have been doing some more scale experiments downstream, and what we found is that when making KubeWord update or patch calls, the there is an additional latency that is introduced in the Word API by the mutating webhooks. That causes around 60-70% of the latency. Shrija helped us find that out. And we are exploring ways of removing those webhooks and use. So for the validating part, we are planning to use the validating admission policy feature in Kubernetes that just got GA'd. And for the for the mutating webhook on the update path, the only thing that mutating webhook does right now is prevent status updates from non-KubeWord users. So we are thinking of moving that again to the validating admission policy. I think that will completely remove webhook from the mutating webhook from the patch path, and it will help with scaling up and keeping the latency down.
Yeah, interesting. Do you have clarification on the latency? Like, is it just the network call taking so much, or is it really the weird API or the webhook responding slow?
No, it's the so there are two metrics that we looked at. The first metric is from API server on what is the end-to-end webhook execution path, and that was about 70% of the latency. So first we found out that that is the cause. And then we instrumented the mutate function inside of the webhook. And I think that was coming up to be 30 or 40% of the latency. So the mutate function itself in the webhook does encoding and decoding. And I think that is causing some latency, and then the validating webhook is causing some more latency.
So the first part, the 70% you said end to end, does it mean that is it the API, a Kube API server, and then calling to the webhook, or is it only the calling of the to the webhook?
No, it is the Kube API server. So that end to end is from Kube API server starting the webhook call, then going through the network into Vert API,
And
executing.
back.
Yeah, and back. Yeah.
Okay, so it's really the turnaround of the webhook.
Yes.
And in terms of milliseconds or seconds, what are we speaking about?
We were at 600 milliseconds of total patch time, and out of that 70% was that webhook call. So I would say about
400.
100 milliseconds. Yeah.
Okay, and then you said like the 40% of the total, or from the mutating webhook
No,
is
total.
the yeah. But
Total.
the latter you said that okay. We also had a look at the mutate function, and then mutate function is like responsible of 40%, but 40% of the round trip, I
Yeah,
guess.
that's 40% of the total. So it was somewhere between 200 to 300 millisecond. And Shrija, keep me honest if these numbers are not accurate.
So the mutate function is taking around 25% of the round trip time.
Okay. So that would be around 150 milliseconds, something like that.
Yeah.
Yeah, but Lubo, like these numbers look small, but when we plot out in the Grafana, you can see clearly that the you know when there is a spike, the spike also happens on the mutate side, and sometimes the mutate side is all of the spike. Other times it's lesser.
Yeah, I get you. I mean, we had also looked at some internally and some problems, but that were mostly caused by the client side, yeah, like throttling by the number of QPS and bursts that we were setting internally. So I was wondering if that could be the cause, or like overall if it's small. And did you also had a look at the mutating webhooks?
This was all about mutating webhook. We did not.
No, sorry. I mean the cell based in Cube API
Oh,
machinery.
yes. So that's what we are looking at right now. But our mutating and validating webhooks in KubeWord, they do really, really simple things, right? The validating webhook just filters a set of labels, and the mutating webhook just stops the status updates from non-KubeWord account. So the cell expression from validating webhooks will be simpler. And I don't have data yet. Shija is still looking into it, but my hope is that if we move to validating admission policy, it'll be much faster because we save the network round trip time there.
Yeah, yeah. I mean, you do have a penalty for interpreting the language, but probably less than what you get from the network call. With
Yes.
a network call, I would suspect there is all like on average you get 100 or 20 or 200 milliseconds.
Correct. And the interpretation of language part seems to be simpler. So that's the trade-off we're making.
Yeah. So coincidentally, there was a discussion about how do we want to do validation in future, and because somebody was proposing to have the markers in the types from the cube builder, which then reflects in the definition of the CRD, and that is executed by the API, cube API. I was against that, but I didn't attend this discussion because I was on PTO. And it's of course not the solution we need or we want, because we have multi-arch and maybe multi-hypervisor support. What you are saying, the cell, I think that would be plausible. So what I want to say, there will be another discussion about these validations and how we want to do them. If we want to do them only through CRD validation or VAPs or like this cell-based internal or Cube API webhooks, or we want to continue with the webhooks as we have right now. So if you can compile this reasoning of, hey, we had to look at the latency, this is how it looks, etc. Maybe that's a good compelling argument why the KubeVirt as a core should move to the cell-based validation.
Yeah, sure. That was the intention of bringing this discussion here. Shrija is still working on some of the data, but hopefully once we have the data, we'll file an issue. And if you are aware of this discussion happening, please loop us in. We're interested in removing this webhook altogether.
Okay, yeah, I'm thinking that maybe let's do it on the unconference call, which is 10th March, I think, which will be in 2 weeks, I guess.
Yeah,
more than 2 weeks.
sounds good.
And if that's enough time for you to kind of compile this, what you see on your side, and then we can have a discussion about it. The only concern from my side is maybe sometimes we do external call in the validating webhook or mutating, and VAP or like these cell-based Cube API webhooks don't have this capability. So maybe we will be short of some use cases.
That's right. If you want to depend on another object in your webhook validation, then that object, making that object available in the cell context will be a tough ask. If it is the same object, then we already get it from the API server into the cell context directly.
Okay. When you compile your findings, maybe ping me privately, and I'll try to review it. Maybe ask for clarification on some points, if just to make sure that we really cannot, reduce the round trip time on the webhooks to some acceptable threshold. But yeah.
Yeah, sounds like a plan. Thank you, Luba.
Good. Also, for those things which we cannot implement in the cell, I guess we can have a still validated webhook which will be just filtered with cell. So, like for example, I don't know, I would just make an example which probably doesn't make sense. If this has a data volumes, we need to validate the data volumes. Then only then send to this webhook the data. Just one thing to look at, maybe to look at the CPU profile of the webhook, like if it is maybe the marshalling taking majority of the time of execution. There, in the future, we can have the CBAR format, which is adapted in Cube. That could be helpful. So, yeah, just to have a meaningful
factual discussion later.
So that we had that plan for looking at the pre-prof data and figuring out what is causing more problems in the mutate function. However, when we looked at the validating and the mutating webhook implementation, the implementation was so simple that um, it it was not worth it to spend time on that. So we did not end up looking at it. Um, but yeah, I'll revisit that um, for our upstream discussion.
By the way, there is also the schema validation we have. And I'm pretty sure that can be slow and actually duplicate, right? Because I think as of now, that is really duplicated work and probably not needed.
Yeah. Okay. Awesome. Thank you for this discussion. Think we'll um, revisit this in a couple weeks, maybe 3 weeks.
Okay.
Yeah, the date for unconference should be already public. Just don't forget to put it into your calendar.
All right. Good discussion, folks. Okay, I think that's it. That's all we have for time. Fortunately, we didn't hear from Federico. We'll have to get him on the next time. All right, everyone. Thank you. Bye-bye.
Bye.